Hi everyone, Mr. Markwick here. In today's video, I'm going to be showing you how to add 1 and 2 step connectivity matrices or 1, 2 and 3 step connectivity matrices. The purpose or the reason why we would add 1 and 2 step connectivity matrices would be to give us the number of routes from one node to another node, which take at most 2 steps. And the purpose of adding 1, 2, and 3 step connectivity matrices gives us the number of routes of at most 3 steps between 2 certain nodes. And it will obviously show you all of the nodes connected in a certain network. Let's have a look at an example here before we talk too much about the meaning behind each element within a matrix of the form C plus C squared or C plus C squared plus C cubed. Anyway, the network I have here has 5 nodes, P, Q, R, S, and T. And it's connected by a number of arcs. Some of those arcs are 2-way, some are 1-way. The first thing it asks us to do is to find the connectivity matrix C. So we're just gonna, from that network, draw a matrix which represents the number of 1-step connections from the starting matrix, which is represented in the rows, to the finishing matrix, which is represented in the columns. Now, again, we don't usually label our matrix, but it is usually done in alphabetical order. So the rows, row 1 would be node P, row 2 would be node Q, row 3 would be node R, and so on. Column 1 would be node P, column 2 would be node Q, etc. Okay, so that one's already done. Again, I've done a video on connectivity matrices and how to, I guess, create those from a network. So I'm not going to show you that. I did that to save a bit of time. What I'm going to show you in this video is to, or how to add 1-step and 2-step connectivity matrices. So that's what I'm going to do here. I'm going to show you the value of C plus C squared, and I'm going to use the graphics calculator to do that. Now, the last video I showed you on a graphics calculator, I used just the matrix function within the run function here. So I came up with my own ordered matrix. I think it was a 4x4 in my previous video. But today, because we're going to be using that same matrix a couple of times, rather than re-entering it over and over, I'm just going to enter it once. It'll save it in my graphics calculator. I can use it from there. So this is how we do that. If we go back to the main screen, you'll see when you enter your run function, we're going to go straight to the matrix function here, F3. And then you can set up a number of different matrices that you might want to store on your graphics calculator. For me, I'm just going to, at this stage, create one matrix, matrix A, that I'm going to use, and that will be this connectivity matrix for this network. So I'm going to create a 5x5 matrix. So on here, I'm going to press execute. M being the number of rows, I want 5. N being the number of columns, I want 5. Hit execute again, and then we're just putting in our information. So for this, there are a few 1s and a lot of 0s, so I should be able to do this pretty quickly. You bear with me. I think that's it. Okay, now I exit here. That matrix is now saved as matrix A on my graphics calculator, but we know it as the connectivity matrix for this network. Okay, anyway, now I've got it stored in there. Hit exit again, and within this run function, rather than drawing up that matrix again, I can just use matrix A as this matrix. So to do that, Shift 2, you can see MAT for matrix is above 2. So matrix A, alpha A, okay, and then I'm going to add that to matrix A squared, which gives me the matrix of C plus C squared, or the 1 and 2 step matrices added together. So I'm just going to write this down, then we'll talk about what some of those values represent. Oops. Should have done better than that one. 2. Good. No, that wasn't better. That's better. Okay, cool. I think I've copied that down correctly. Now, the next question says, let's look at this question first, and we'll talk about what some of the other values represent. So what do the zeros in C plus C squared tell us about the network? Well, it tells us that we can't, the zeros tell us that we can't get from one node to another node, or we can't travel from one node to all other possible nodes with at most 2 steps. Some nodes to get to require more than 2 steps from another node. For example, like this 0 here, maybe that I didn't explain that very well, but this 0 here, again, we're talking about the first row and the third column. So from node P to node R, we cannot travel from node P to node R in at most 2 steps. We need more than 2 steps to get from P to R, okay, if it's possible at all. There is no way of getting from P to R in 2 steps. That's what that 0 represents. Again, likewise, this 0 over here, because it's in the third row and the 5th column, the third row is talking about R, and the 5th column is talking about T. So we cannot travel from R to T in at most 2 steps. Okay, we need more than 2 steps to get from R to T in this network. Okay, it's as simple as that. The ones mean that it is possible to get from one node to another node in this network via a maximum of 2 steps. And the 2s mean that there are 2 possible routes to travel from one node to another node within this network at most 2 steps. So let's look at one that has a 1-step and a 2-step route and is represented by a 2. So for example, let's take what are we? 1, 2, 3, 4. So let's take this one here, this number 2. So that number 2 suggests that there are 2 routes of at most 2 steps from node S to node Q. Okay, so from node S to node Q, there are 2 ways of getting there in at most 2 steps. The first way of getting from S to Q, 1, 2, is to go via R. That takes 2 steps. And the other way to get from S to Q is just to go straight there. Okay? They are the 2 routes of at most 2 steps. Okay, yes, there was one that was 1 step and there was one that was 2 steps, but that's what it's showing. It's showing that there are 2 ways of getting from one node to another node of at most here 2 steps, because we're adding the 1 and the 2-step matrices together. Now, that pretty much wraps up the example, but I do want to just quickly show you a 3-step, or adding as well a 3-step connectivity matrix to this as well. So for example, what I'm saying is if we had C plus C squared plus C cubed, all right, that would then show me the number of routes within this network that are possible of at most 3 steps between certain nodes. Okay, so again, on my graphics calculator, I've got that matrix saved. So it is literally just going to be matrix A plus matrix A squared plus matrix A cubed. And it then will give me this here. So let's just quickly write that down. Three, 3, 1, 3, 1. 1, 2, 1, 1, 1. 2, 3, 2, 2, 1. And 4, 5, 2, 4, 2, 4, 5. Okay, so this then shows that there are no zeros. So there is travel possible within all of these nodes, between all these nodes, of at most 3 steps. So you can get from any node to any other node in this network in 3 steps at most. Okay, and again, it doesn't show this. This number 5 here. Let's look at that, for example. That doesn't mean that there are 5 3-step routes from T to Q. It shows that there are 5 routes from T to Q of at most 3 steps. Okay, so let's go ahead and actually, just for the sake of this, really quickly try and identify what those 5 are. This could be tricky because I haven't planned this ahead, but let's have a go. So the first route that we're talking about there from, so remember, this is row T, okay? So from T to column Q. So T is our starting, Q is our finishing. So from T to Q, that's our first one right there. Okay, it's only 1 step. The second one, I could go from T to P, back to T to Q. That was 3 whole steps, so that's 2 so far. I'll just keep a tally here. From T to S, S to Q, that's 3. I could go, I can see one here that I wouldn't have found. So T to Q to S, back to Q, all right? So again, that's not really an efficient one, okay? But again, these don't, the limitation here of these matrices, of the connectivity matrices, really are that they don't show the most efficient route or path. The last one would be T to S to R to Q. So that's the 5 possible routes from T to Q of at most 3 steps. You saw some of those were 2 steps, some one of them was 1 step, some were 3 steps, but they're showing there's 5 possible ways to get from T to Q in at most 3 steps. All right, so that's basically the purpose of adding those 1, 2, and 3 step matrices together. It shows you the total number of routes possible of at most either of at most 2 or 3 steps. Okay, hopefully that helps. This pretty much wraps up what we'll be doing in year 12 around connectivity matrices. Next thing we'll look at, my next video will be around dominance matrices.